I'm Stepan. I work for Oracle Labs, and we are working on a project called FastR, which is an alternative implementation of the R programming language. This talk will actually be sort of a follow-up, or will build up on the previous talk about the future package. So yeah, I'll talk about it later in the presentation. What is FastR? As I said, alternative implementation of the R programming language. It's built on top of something called GNU-R platform, which is a platform or framework for building various programming languages. FastR is licensed under GPL v3. It's derived from GNU-R, so it will always be licensed under GPL. Right. So that you can get an idea how FastR looks like, it basically looks like GNU-R. If you download and start FastR, you're going to see the welcome message that you're used to, except for the first line or second line where it says Oracle, and the first line where it says FastR. And then you can run your things inside FastR, and it should be exactly the same as GNU-R. So if it is exactly the same as GNU-R, why would you care about FastR? FastR is significantly faster with certain R code, especially loopy R code with scalar operations. On last year's useR, I was presenting this example that calculates some ray tracing algorithm that was originally written in mixture of R and Fortran and C. And I rewritten the whole thing into R and run the benchmark, and here you can see the results. So as you can see, FastR can be, especially if you have plain R code without C, FastR can be significantly faster. Another reason why to use FastR, it's built upon this infrastructure, and we built other languages upon this infrastructure, and they can all cooperate together running on the same platform. And this means that the communication between the languages doesn't have to cross any expensive boundaries, and it can be fast. So what I did with the same example, I rewrote one of the Fortran functions to Python instead of rewriting it to R, which I did in the previous example. And I run that on FastR and GraalPython, which is our Python implementation on GraalVM. And as you can see, it's not as fast as pure R, but it's definitely faster than GNU-R. So, you know, if you combine R and Python on FastR, then you're going to be faster than R and Fortran on GNU-R for this specific benchmark and for this specific type of code. By the way, this plot is an SVG image which was done in FastR using ggplot2. Another reason why to use FastR, it's built on this GraalVM platform, and there is lots of tools that work with this GraalVM platform, and naturally they work with FastR as well. This is a screenshot from a profiler that runs in parallel with the application, so it shows you live results from your application, and you can see the stack traces for which functions take long time, etc. Another reason this whole GraalVM thing, I didn't say that yet, but it's built up on the JVM virtual machine, and that means that we are very good at interoperability with Java and at embedding FastR into Java. So this is a Java desktop application, and the plot was generated in FastR, and it was directly drawn on the Java widget. So there was no like bitmap image generated on a disk and then displayed in the UI. It was directly drawn on the UI. So now you may ask, what's the catch? And you know, it's good to reach out to authorities. So as Hadley Wickham says, it's hard task to make an alternative implementation. Can you imagine having to re-implement every function in base R, not to be only faster, but also to have exactly the same documented bugs? And to that, I would add exactly the same documented and undocumented bugs, because people rely upon them more often than you would think. So now we talked about FastR, and the title of the talk is FastRCluster. So let's focus on the second part, the cluster part. It refers to the parallel package, where you can create PSOC clusters. PSOC cluster is basically another R process that can run on your machine or on a different machine, and that's spawned by your main R process, and then you can offload some computations to that process, and there is a protocol with which those two processes communicate. As it happens, FastR implements everything that is necessary for this as well, because we want to be compatible with GNU-R. So what you can actually do is that from GNU-R, you don't spawn another GNU-R process, but you spawn FastR process, and you communicate with it. And that's the FastRCluster package. So this is how you can install it. If you install the package, then you need FastR as well. You can install it with this function that will install it into your library, into your R library where the FastRCluster package was installed. Or if you already have FastR and GraalVM installed, you can configure it like so. There's one thing I forgot to put on the slides, but I need to mention it. So far, FastR works only on Linux and Mac OS. We are working on Windows support. We might actually provide a Windows support through Docker in a short time, but yeah, that's something we're working on. So let's look at the demo. This is actually RStudio. You may not know this, but FastR unfortunately doesn't work on RStudio yet, but GNU-R does. So what we can do in RStudio, we can install the FastRCluster package and run FastR through that. So this is how the documentation works for the FastRCluster. And now let's do something interesting. We can create a FastRCluster node. By default, it creates the make FastRCluster function, creates a single node. And then we can use the parallel package to communicate with that node. So what we can do, we can run a code that says r.version, but we run that on FastR. So as you can see, the output down there mentions that the R engine is FastR. This is a field that GNU-R doesn't have in this r.version global variable. So this is a way how we can distinguish where we are actually running. There is a helper function called FastR, to which you just give the FastR node and a piece of code, and it will evaluate this on the FastR node. So it's basically a shortcut of the cluster apply function. And so now let's do something more interesting. What we can do is we can run ggplot2 on FastR, generate a ggplot2 graph, but don't plot it yet. We're going to send it back to GNU-R, and then we're going to plot it in RStudio. So as you can see, the graph itself was generated in FastR, but only plotted in RStudio. We can take the very same code and then run it directly in RStudio. And as you can see, the title of the graph is different. We don't have the engine name there anymore, and it's a different process ID. And so now let's do something even a bit more interesting. We have here a large data set and a function that I called my computation, and I'm going to use the parallel cluster export function to make those available on the cluster on the FastR node, and then I'm going to invoke that function on that large data set, and I'm going to get back the result. What is interesting about this is that if I measure this, and now I am, oh sorry, so now, yeah, okay, so this slide contains both measurements. So if I run this on FastR and measure this, then even with the overhead of the transformation of the data back and forth, you can see that the FastR is significantly faster for this specific piece of code that uses loops and scalar operations. So yeah, so that's that. The second line runs the same code on GNU-R. Yes, another thing, and that's why I was saying I will build upon the previous presentation, is that this whole interface works well with the future package. And I guess I don't have to go through this because it's been all set, but there's this package called promises, which you can use in your Shiny applications to offload things from the main web server thread. So this is how it looks like. We've seen that already. Now let's take a look at the actual example. This is an application that draws a Mandelbrot set. It computes Mandelbrot set and it draws it. The original code that I've taken from this GitHub repository was written in C, and I've rewritten this to R. So it's a loopy code, good for FastR, and it does take some time to compute. This is how it looks like in R. This is how it looks like with Shiny running in GNU-R and the future backend being the FastRCluster running GNU-R. You can see that the data got generated is something around 30 seconds. Now if we imagine you have application like this, the only thing you need to do is just change the backend for the future package, like so. So you create your FastR nodes, and then you just say plan cluster and workers equals your FastR nodes. And what you can get then is running time of about a second. Now bear in mind, this is a specific example that was crafted in a way that it runs well in FastR, but I think that's the sort of point of this package. If you have loopy algorithms and you are not happy about GNU-R's performance, what you can think about is using this package, FastRCluster, and offload only those loops to FastR. Make them faster, but keep the rest of your application in GNU-R and be sure that it's just gonna work. Because as I said, we are working on compatibility with GNU-R. We want to be 100% compatible with GNU-R, but that's of course a long road there. So that brings me to the summary. FastRCluster package lets you run FastR in GNU-R, and that includes in RStudio. And FastR itself is an alternative R implementation that can run specific R code significantly faster and has a few other additional features. So we are on GitHub. We are open source, GPL licensed. You can contribute. You can send us issues. You can talk to me after the presentation, whatever. We would like to find out what people would like to use FastR for and what's important for you. So talk to us, and yeah, we will make it happen. Thank you.
So we have time for questions.
Thanks for the interesting talk. So my question is about the protocol that you use, in your cluster. Is that perfect? Is that compatible with the protocol the parallel package uses? That's why the future just works?
Yeah, exactly. So that's we have implemented the same serialization as GNU-R. So of course modulo issues that we haven't found yet, but we should be compatible there. Yes.
All right. Thanks.
Thanks for the great talk. I'm curious, are there limitations in terms of what can be transmitted to the FastR process, in particular, if you have a closure written in plain R? Is that going to work?
Yeah, thanks for the question. In theory, everything should work. Like with the FastRCluster on GNU-R. If your code works on GNU-R with the FastRCluster and parallel package, it should just work on FastR as well. Of course, as I said, modulo bugs that we haven't seen yet, that people didn't report to us yet, but yes.
Did you run a command check on several packages just to have an idea of the amounts of packages that are still compatible or not with FastR?
Yeah. Thank you for the question. It's it turns out it's not that easy to find out if packages are compatible with FastR. Packages, not every package has tested tests, which tests are great. We can actually measure how compatible we are with a package by the number of passed and not passed tests. But many packages just have vignettes, examples, tests without expected output, and there it's a bit difficult. We are trying to textually compare the outputs with GNU-R, but then there are differences which are actually not errors, and so on and so forth. So unfortunately, I don't have a definite answer for you, because we have some internal results, but I think they are influenced by the infrastructure as well. We do monitor some important packages, like the tidyverse packages, so on and so forth. So to give you an example, like RCPP, for example, should work fine on FastR. We monitor that package, and we are making sure it works. ggplot2 dplyr, etc. What we do a small trick there because when people submit packages to CRAN, CRAN checks them against GNU-R, but not against FastR, obviously. So what we do is that we use a snapshot of CRAN, fixed snapshot of CRAN, so that we can make sure that the packages from that snapshot work well on FastR. And then every now and then we move the snapshot forward, but as we do that, we check the important packages and we check that they work on FastR.
So let's thank Stepan again. And also let's thank all the other speakers again. Like I'm so happy that you are working on the performance of R. Yeah.
Thank you. Thank you.